Before I dive into the lecture, let's see some live presentation. This demo is about 2 years old, and like I mentioned before about the metaphor of the little birds and the planes, the jumbo jets. Birds and jets sometimes don't mix together. We are more like a single engine Cessna flying around. So yes, we do make things for fun, but we sometimes try to sell them. And of course, gaming is fun. So one of the fields that we are studying is how the interface in the living room will look like in the near years. So we built several mock-ups showing the interface for the living room. So imagine that I'm sitting in my living room and I want to control the system. I can perform some kind of focus gesture, and then maybe I lock the system if I need it. And then I operate the system using a certain control or console on the bottom, which we call it a soft bar. Give some more details about it later. Let's say I want to see some pictures. It's not my family's pictures, but it's very hard now. And I switch among those pictures, and again, you can look at my hand motion. Really subtle motion of my hand can switch between those pictures. And the bar itself, again, I'm originally coming from the cellular industry where you had a lot of use of soft buttons. The bar itself is a kind of control that can change its state according to the application state. So if I'm now playing a video, I can use it to control the volume and to play and pause. It's like really easy to reach the left and right edges. I can do maybe control do fast forward, rewind, slow motion, time sync, and all this with very small motions of my hand. So this is a demo, like I said, about 2 years ago. Let's switch to another demo. For those demos, new portal. So let's jump to version 3.5. Okay, so this demo uses a different paradigm, maybe a more familiar paradigm that is a cursor-like paradigm. Again, I'm now in the living room, I want to control the system, I perform focus gesture, and then I get a sort of hand avatar that moves me with my hand. You can see the hand avatar moves. It's not really my fingers. It's the same hand point that you are well acquainted, at least those of you that played a bit with OpenNI. And I can watch pictures. I can perform gestures similar to what you do maybe in the iPad. And once I found a picture that interests me, I can zoom into the picture. The picture here of my son, I really wanted to find him. Okay, next time. And also here, I can, if I'm lost in the system, I can pull down a sort of a curtain menu from above and return home. Maybe watch some movies. So again, I have all sorts of movies. I can pick a certain movie, see the movie details, and start playing it. So imagine that I'm now sitting in my living room and there's a call or someone tries to talk to me. Every time, if you had a remote, you just simply had to quickly press the mute. If it was on-demand video, maybe you want to pause the film. It's another action you have to perform really quickly. So you see the center element consists of the pause and play control. You can move to the side to control the volume. And you can do a time sync on the bottom. Again, quickly jump home using the upper curtain. Okay. Before I continue, I would like to give a few credits, mainly I say to Professor Mark Wallace from the USC. He's the guy that kind of helped educate this group of engineers, arrogant engineers maybe, and help us know a great deal, learn of the world of interaction design and user experience. Now, let's begin talking a bit about the team. The team consists of engineers originally, but now also of some designers and researchers. What we try to do is not build the usual user interface or study more where to put which menus and which menu items and when and where. You can imagine that when you go to a certain application, you want to build an application on top of existing basic building blocks. You begin by designing the basic language of the layout, saying I have a button on the left, a menu high above, things like that. We call it the layout layer. On top of it, you continue, and again, an application like a media center or cell phone maybe has 200 different states, all reflected and using the basic layout scheme. Our focus is below that, below the layout. Our focus is the core mechanics of how you track the motion, which motion you need to track, and what are the reusable building blocks or primitives that you can build on top of it and then give it to the interaction designers that can further use it on the layout design. And those primitives are something that are similar to, like I said, buttons, menus, sliders. This is the level I'm talking about. Okay, so one thing happens to me a lot is that people tell me, hey, look at this Kinect, it's great for gaming, but I really like my remote. You know, I just want to zip up and down channels, and so I don't want to do any large motions, and I don't need any motion capture for that. Imagine what will happen in the future. I mean, it's already happening. So how many of you have TV larger than 40 inches? Okay, the rest should upgrade really quickly. I don't have a TV, by the way, but I probably should not say it here. But our walls already turning into something active, something that can change how it looks. You go to a doctor in the waiting room, you'll see a big flat screen TV. There are signs all around them, and you really don't want to touch all those displays in order to interact with them. And there are many different reasons on top of it on why gesture interface makes sense. I can tell you a story. I mean, yesterday I arrived again after 15 hours of flight to the hotel, and the TV was very loud, and working in PrimeSense when it's loud and automatically start shutting down this response. And this I said, damn, I really need it. I don't, even just the fact that I don't search for a remote, it's a magic by itself. So I was mad about the TV, so I stole the remote, but this is later on. When you talk about, I mean, one thing I will not do today is tell you, okay, this is the winning paradigm. Let's all switch to this new paradigm, and that's it. I think it's only the tip of the iceberg, and there is so much to study and discover and create in this field. And I'm quite sure this field is going to revolutionize how we interact with machines in the coming 10 years. So one of the things that you do when you work with interfaces is you try to classify them. You saw the soft bar before. There are other paradigms like virtual touch screens, cursors. Sometimes you can classify according to the viewpoint. Again, borrowed from gaming industry, like first person, third person. They borrow it from linguistics, so it's okay, I think. And maybe also second person. I call it, if you see it, it's like a mirror, I call it second person. And there are all sorts of different paradigms. And usually when you think of new paradigm, you can find similarities and try to classify it. Now, this is the demo you saw even before you saw earlier. This is the first prototype more than 2 years ago that used the soft bar idea. Actually, one of the guys who made it is here. Roy? No? Okay. Currently in Zigfoo, previously in PrimeSense. And the idea is that in order to sit comfortably in the living room, it's better if you don't do a lot of motions. You move most of the motions are horizontal motions, and you don't really need to lift your hand from the armrest. And you can see here different applications like switching movies and such. But again, the basic control idea is that you have a bar in the bottom, and it really felt great, even though it's very, very simple. Now we move further in time, and we took the same idea of the soft bar and gave a name to it. So again, it's a soft, just like a soft button, and the interaction designer, when you use the soft bar, you can just, for each state of the application, design which items are on the soft bar, how high they are, what happens when you hover over them, and what happens when you select them by motion up. If you move your hand down, it's like saying I want to lose control. Okay, let's continue. Okay, so this demo is it's not running. Okay, so this is. Some of you may recognize this the UI in the background. This is simply XBMC, the Xbox Media Center open source project. And this is a very quick mock-up trying to combine a joypad on one plane with a soft bar inside. So actually when you control it, you control the joypad here by moving the point. The point is one-to-one map to your hand, just like a small cursor in the button. And if you want to reach, instead of selecting like that, pushing forward, reaching forward, simply move between two layers of the interface. So even though it's very, very simple, it's already using the 3D aspect of the interface. And there was something really nice in simply zooming in and zooming out when you switch between those two layers. And again, what you see here is simply the only demo, the mock-up that we made is the overlay on the button. It simply sends a quick keystroke to the application in the background. Okay, so this is actually the first demo that PrimeSense did that was outside the gaming. This is, I think, about 5 years old. And maybe now today doing a multi-touch gesture seems like a commodity. But I really hate this demo because every time I show it, eventually that's what people remember, and that's what they see. And because it's really great, and I saw there are several nice Kinect hacks that use the same idea. It's a virtual touchscreen with a certain plane on the z-axis. And it's really cool if you try to use it while you're standing. Even though if you look at it, you think, I will have a lot of control, but in reality, it's not that easy to control it. But it uses rather simple computer vision algorithms behind it, and it looks awesome. I mean, this is when you use, you feel like Tom Cruise in Minority Report. I mean, before he was the suspect. Okay. So this is another demo that uses a cursor-based control. You see the flare? This is cursor. Some of us don't like to think that we're still using cursor, but in my own opinion is that cursor served humanity for a long time, and they will continue to serve humanity. You can sometimes refer to it as handlight. Again, just not to say cursor. This is using the hand tracking algorithm, the computer vision algorithm that was eventually evolved to what you have today in the NITE library. Okay, so this is the demo that you saw before. Notice some small details about the importance of visual feedback. If you see you can see the reflection of the hand avatar. Now the hand avatar reflection, it's a great way to give a sensation of distance from the surface. You can use reflectance, you can use shadows. Using reflectance gives you the sensation of something more expensive, by the way, because it looks glossy. So use reflection is better. But it's giving the sensation of the distance from this virtual touchscreen is one of the main critical points in order to make it successful. Remember that, again, I'm coming from the cellular industry. I remember many times that I heard the leaders of this industry, the top tier handset manufacturers, explain why people will not want to use phones with buttons, with touchscreen, sorry, and why buttons are here to stay. And they have perfectly good reasons saying, okay, I use the phone while I'm walking and while I'm driving, and I want to feel the button, of course. But ever since everyone started buying those iPhones, people cannot say that you cannot use touchscreens anymore, I think. And one of the things that made the iPhone work better, I mean, you don't have the same tactile feedback as you get in buttons. And yes, you cannot use the iPhone without looking at the screen. But they did quite a lot to compensate for the lack of tactile feedback, using animations, using sounds, and using smart algorithms behind the scenes, which I call mechanics, that help to compensate for the lack of tactile feedback. For gesture interfaces, those mechanisms are really mandatory. And it's very important to notice how it's going to give as much as possible cues for the user to compensate for the lack of tactile feedback. So let's move back. Now I know why my boss always complained that I neglect the PowerPoint viewer application. We also had a test showing usage of 2 hands. About a year ago I fell in the bathroom, don't tell anyone, and I fell on my left hand, and I didn't break it, but the doctor thought I had one of the bones here cracked, and he put some thing on my hand that I couldn't really use it. But it was my left hand, who cares, right? I'm right-handed, it's no problem. But after a month without using my left hand, I came to appreciate it much more than before. Imagine that you are going late at night to grab something from the fridge. You open the fridge with one hand and pick up the healthy food in the other. And or even imagine that you sit on your desk. Your whole desk is planned for a 2-handed user. You have phone on one hand, one side. You have maybe your mouse on the other side. Now, you can use everything with one hand, right? But then it became very awkward. Same is true for natural user interfaces and natural interaction. Just the fact that you have 2 hands and you can use it actually reduces the fatigue and stress people feel when they are working with the application. Okay, so many people say when they hear the term natural interfaces, what they say is the most natural thing is talking. People talk all the time, so yes, talking is natural. How many of you saw the movie? I mean, some of you are too young. Saw the movie Total Recall. Okay. How many of you want to fight with Arnold Schwarzenegger? No. Another person. So, in this movie, there is a scene where he goes to Mars, and there is an amazing taxi called Johnny Cab. And Johnny Cab is like a puppet saying, where do you want to go? At the beginning, it's really cool. Just state your destination, and there he goes there. No need to drive. In the second scene that we meet Johnny Cab, there are like 3 armed people running after Arnie. And at this stage, Johnny still asks, where do you want to go? State the the destination, but this time the customer don't have as much patience as before. We simply want to drive. So then something violent happens to that Johnny, fell on the floor after he get broken. But yes, sometimes you need a tool. The whole metaphor of some virtual assistant helping you all the time, and I cross my fingers that the Apple Siri is not a hoax. Even though you have it, and I'm sure that in the future you'll see interfaces like that, like the ship's computer in Star Trek, something like that, that will tell you the ship is going to self-destruct very calmly. I'm still pretty sure that there are many cases where humans will want the tool and not the assistant. Okay, when you're building gesture interfaces, one of the problems is that the interface sticks to your hand. Imagine this remote control that, again, I retaliated to the TV that didn't respond to my gesture, so I took its remote. I promised to give it back this evening. And the remote control, one thing cool about it, it has a clear session model behind it. So imagine that the remote is here. Who is using the remote? No one. No one is controlling the TV. Now I'm controlling the TV, right? But I didn't press any button yet. And then I can do some kind of activation and press some buttons on it. So this is the basic model that people got used to when they have remote controls. Now let's think about gesture. This thing gets stuck to my hand. It's not pleasant. It's cool when I want to use it, but if it gets mad when I don't want it, it's totally uncool. So building a proper session management is something essential in order to develop successful gestural user interfaces. Those of you who saw the Kinect Hub, you see the way that you need to first wave your hand, and the effective feedback that you see on screen every time the hand moves from left to right, telling you, I saw you, I detect your motion. And later on, you are in session and you can just raise your hand and control more easily. Sometimes you are torn in the dilemma between defining gestures that are simple, so it will be easy for the user to apply them, by the fact that you want to have any false rates or high false rates for false detections. And when you're in such a dilemma, one of the proper way to tackle it is to if you are making a gesture which is not that simple, to break it down into steps and give effective user feedback on every intermediate step. Again, the Kinect Wave example and the Kinect Hub is a perfect example for that. You can, if you look closely at the demos, you'll also see such kind of intermediate feedback happening as I engage the system. Okay, we already talked a bit about feedback. Oh, what did I tell you? Okay, so these were not made in Illustrator. When you talk about feedback, you say, okay, so the feedback needs to be smooth, needs to be continuous, right? Wrong. It's not always the case. Sometimes you want to let the user feel as if his motions are free and nothing special happens along the z-axis. You can do something continuous, but usually, even if this is how you design your feedback, the moment of touch, if it is a virtual surface or some kind of virtual control, should be followed by a non-continuous change to the visual feedback. It can be, if we have a circle, one of the cursor shapes was a circle shape, shrinking very quickly, and so if you are far away from the surface, everything is continuous, but once you reach it, it has something that is not continuous. The hand avatar that you saw before, I call it sometimes a super metaphor for the cursor, because two things happen. First of all, people understand this is their hand, this is okay. But the other thing happens is that people start to mimic the hand, just because it almost looks realistic. So instead of holding the hand like that, which will cause a lot of fatigue in your radial bones, around your radial bones and muscles here, people start holding the hand like we saw in the metaphor. And when the metaphor is holding something, even though the user didn't do it intentionally, if it's just by hovering, it will hold something, the user just imitates it. So we are all a bunch of monkeys. We imitate what we do, and we like to see the things back shown to us, how we imitate it. And the hand by itself, if you want to operate with hand, it's not good for all applications, but sometimes it's very effective. One-to-one mapping here is simply, just friends. One-to-one mapping back in the day in the Atari 2600 console. You had a pedal. That was one-to-one mapping. That's cool. So today one-to-one mapping is a trend. You should use one-to-one mapping in many cases because it's cool, it's working. And about sounds, I cannot overestimate it. Every time we fall into the same trap, you have a new idea, let's just write around, let's write a small mock-up, because we write small mock-up on a daily basis. Forget about the sound for now, but sounds change everything. It's really hard to make a successful paradigm, and even imagine it, even if you're a pro in this field without adding some sound. Okay, another aspect of the evolution, maybe first let's go back to the graphical user interface revolution. And what you see here is the cockpit of a Boeing 737 airliner and how it changed over 30 years. That doesn't look much. Not all industries are that quick. But one thing that you'll see is that the main thing that happened is that the display got soft. In the original design of the cockpit, you had a lot of gauges, dials, sliders, things like that. In the new design, you still have a lot of them, but some of them were replaced by screens that show the data preferred by the pilot, or sometimes if you have, for example, some kind of valve got broken in some kind of engine, the pilot don't need to hear a beep and run to the back because there are many more dials and gauges behind him. He can see it right in front of him. And those displays usually have less contrast than the original mechanical dials and gauges, but still, it's very effective, and this happened. And this is what we see today. The display change according to the application and the application state. And for us, saying that the computer screen is the ultimate display, that it's totally soft. Every time we see what we need to the current application. Now, one thing that I can tell you, a story that we saw in very small details. If you remember the new portal application that you saw earlier with the hand avatar, you have a little back button on the upper right corner, and we had a dilemma there because you need to have the back button all the time, but if you make it too small, then people will not be able to hit it. But on the other hand, you don't want to make it too big, to just look ugly. And if you look at its mechanical designs, you see that, for example, the off button is slightly depressed, so it will be harder to press it. While other buttons simply are raised above the rest of the buttons to make it easier to press them. So actually, when you're building natural interaction interfaces, you can play with the same parameters as you do in mechanical design. So we could simply take this back button and make it more shallow. So even though it is far away and small, the user can press it really easily. Where if by user testing we discover that a certain button in the center gets too much false pressing, accidental pressing, we can make it deeper. So the off button maybe is deeper in order to make it harder to push accidentally. And all those parameters, you don't see them today in the design documents, but you're going to see them very soon because the design of the interface is not only what you see on the screen, but it's also what's happening around the user in the real world. Okay. This, I just said happening around the user. Let's talk a bit about coordinate systems. How many of you know what I'm talking about when I say projective coordinates, real-world coordinates? So all taken from the OpenNI language. Okay, thank you. So one of the first things that we did in PrimeSense that was trivial is just to fix the perspective. So we took the 2D sensor, we took the coordinates from the 2D sensor, and because we know the depth of each pixel, and instead of telling the user that your hand moved by 50 pixels, we can switch to real-world coordinates, fix the perspective, and make the correct perspective in the real world. But the user does not work really in the real world. The user works in his mind. And for example, if I would have been working right now with the screen and I'm sitting here, I will not do this if I want to do Z motion, right? I will do something to all the screen. And if I'm working now and I'm a bit lazy, and you look at the trajectory of my hand points, you'll notice that they are curved because the motion is created by the movement of around my joints. If I'm sitting, maybe it's around one joint, but if I'm standing, maybe it's another joint. And there's actually a difference between a standing and a sitting user, and a sitting user that is leaning forward, as if he's trying to be very highly engaged with the interface, or a user that is the usual couch potato that just sits back and try to control everything without raising his hand at all. So one of the things that we do is what we call subjective correction. This means we try to take the real-world coordinates, understand the user, and how the user is placed in space compared to the screen, and try to reach a transformation that will resemble the perceived coordinate system that the user feels. By applying such techniques, we were able to develop a touch-based touch emulation, like you saw in the previous demos, that you can actually operate in the real world without a lot of practice, and also enjoy the Z-axis without too much accidental motion on the X and Y plane. When you design interfaces, and it's true always for design, usually the implementer or designer is the worst one to evaluate it. Because you already know what it is. The mental model of the interface is what you had in your mind when you designed it, and you are totally biased. So the designer cannot test it, of course the programmer cannot test it, and not his parents too. Tried it, they are always very happy by it. And you need to take user testing really seriously. So we have user testing in PrimeSense. Actually, we have a much newer lab that looks like a real living room. I don't know if any of you have DMX control, the lighting halogens in your real living room, but we have another one that is more relaxing to enter. We can actually take a user, kick him in, and try to see what we get in the first encounter if we don't say anything to the user. What he tries to do, how he tries to interpret the feedback that he gets from the system, what kind of gestures he tries to apply. And later on, we also, after a short training, try to see what the user will get to if the mental model of the paradigm is fully clear to him. So he knows how to operate it. It's usually the most effective way is looking at someone else who's operating it and evaluate what we got there. Another cool activity that we have is something we call NITE byte. Now in Hebrew, byte equals home. So the at-home testing is called NITE byte. This program actually consists of boxes, a small form factor PC that we give as kits to people. We have like 25 units of those. and everything there is fully automatic, so you can just plug it in, you even give the HDMI cable. User can plug it in their own homes, at their own living room, at the real condition, and try to play with the system and work with the system as if, even though it's a mock-up, we bring it to a level that users can actually enjoy it. And the effective thing about it, anyone that did user testing before know that this process is really tedious. You need to look at the user, understand them, not just listen to what they say, but understand what they think. If they smile, then they're happy. I don't care if they're saying the interface is not good. And but working with each user can take an hour or more, and you need several people just to summon recruit the testers, and it's really slow and complicated, and nothing can replace it. I mean, it's still the core way to research. You need to look at users. But when we give such units homes, you can just spread them out on the weekend and come back on Sunday, because we come back on Sunday on Israel, and boom, we get like 20 different questionnaires filled with people saying what they feel, how they felt, and maybe also with log of their problems, and sometimes log of recording of their problems. There are privacy concerns, yes. So this is the NITE byte, and it's also very important to try to find some objective criteria for successful problems that you try to tackle. So it's really hard to create objective criteria, but for specific tasks like accuracy of a cursor, you can actually create programs and create several programs just to measure it, and then you can call it a pseudo objective criteria, because you still let user, you don't have to operate it on offline content, but it's a way to evaluate where you are, and if you made a lot of changes, did you really improve or went backward? And if you don't have this criteria, this means that it will take you another few days again. Recruit all the user testing guys and until you get some results, and those results are always very, very fuzzy.